Alright, let's look at 4.1. This is called linear inequalities in two variables. And then in section 4.2 we'll talk about linear programming. Alright, so in 4.1 they give you this equation or inequality and ask you to graph it on the number line or on the xy coordinate system. So you graph y equals 2x minus 1. So that means minus 1 is one of the points, and then to find another point you just rise 2 and run 1. Rise 2 and run 1. There you go. Connect the dots. Now you don't know which side to shade initially, so check a test point on one side or the other. Let's try 0, 0 that's on this side. Plug in 0 for y and 0 for x, so you get 0 is less than minus 1. Well, 0 is not less than minus 1, so that side, that didn't work. So you shade the other side. If it did work, you'd shade that side. That's all you have to do. So number 3, you want to find your x and y intercepts by setting x equal to 0 or y equals 0, and you get your 2 points, 2, 0 and 0, 4. Now how do I know which way to shade? Well, I try 0, 0 here, if you can. If your line goes through 0, 0, you can't choose 0, 0. You got to pick a point that's clearly on one side or the other. So plug in 0, 0 and you get 0 over 2 plus 0 over 4 is less than 1. So is 0 less than 1? Yes. So we're going to shade this side here. Alright, number 7. They already give you the graph and they ask you to shade properly. Now with a lot of these problems they're going to give you a bunch of equations or inequalities. Number 7, it says x plus 4y less than or equal to 60. 4x plus 2y less than or equal to 100. X is greater than or equal to 0. Y is greater than or equal to 0. Alright, so these last two are restricting you to the first quadrant, quadrant 1. But remember, you got to shade that line and put a y equals 0 on the end of it, and shade that line and put a x equals 0 to represent these two lines. But you also have these two. Okay, they graphed them, graphed each line by using points. And now you want to find all of these places where these lines intersect. These are called corners. This one is 0, 0. You don't have to do any work to show that one. This one's 0, 15. I found that one by letting y equals 0 and I get x equals 0 and I get y equals 15. I found this one by letting y equals 0 and I got x equals 25. Now this one here is the tough one. This one, I call this one a floater because it's floating out there. It's not an x or a y intercept. So you take that line and you put them together into a system of equations and you solve it. Okay, so what I did was I multiplied the first one by -4, and when I added them, now my x's will go away and my y's will be the only thing left, and I can solve and know what y is. You want to line them up. You want to multiply by some number so that the variables of one term will cancel out. So I lined up my x's to be opposites, 4 and -4. My y's will not be opposites, but they will tell me what y is as I solve it. Now I plug this back into the first equation, and I can figure out what x is. Now I know that that's 20, 10. Now how do I shade? Well, we know that these two guys are going to tell us quadrant 1. But these two guys, we've got to figure them out. Well, x plus y equals 60 is here. So let's try something on this side. I guess we could try 0, 0 because it's clearly on this side of that line. So when you try 0 plus 0 is less than 60, you get a true statement. So you're shading this side, including this here. Okay, and then this one, that's the same one. Okay, this one, we write it as an equation here, but we write an inequality here. Okay, so now when we want to check the inequality, we check something on this side, maybe 5, 5. Okay, you plug in 5 for x and 5 for y, and you get 20 plus 10, or 30 is less than 100. That's true. So you're going to shade this side. Now where does this one overlap with that one? Well, if you look at the first shading, you have something like this, and then with the second shading, it looks something like this. Okay, and so what is your answer? It's where you've got both shaded. So you're talking about this area here. Alright. Question 11, they give you the lines already and they just ask you to find the corners. Well, once you shade everything, once you pick some values like 0, 0, you're going to find with every single one of these it's not true. 0 plus 0 is greater than 6, not true. 0 plus 0 is greater than 10, not true. 0 plus 0 is greater than 5, not true. So you do not shade this side of each of these lines, you shade the other side. And where do they overlap? Right here. Alright? And then you also have y equals 0 and x equals 0. Alright? So when you're looking at that shaded region, you've got this guy here. Okay, so you got a corner, a corner, a corner, and a corner. Now notice there's some other corners like these two and these two you don't need to know. And you don't need to know that one either. So don't just try everything with everything. Be careful what you choose. So this one is 3x plus y equals 5. So I'm going to find the y-intercept for that one, right there. And so I get 0, 5. And now this one is x plus 3y equals 6. And I'm going to try the x-intercept by setting y equal to 0, and I get 6. So I know it's 6, 0. So now these are the only two that I have to worry about. This one and this one. Well, this one, I take the line that's x plus 3y equals 6, and the other line which is 2x plus 4y equals 10, and I solve that. Now how can I solve that? Well, if this one's positive 2x, I just make that one negative 2x by multiplying by negative 2, and my x's will cancel. Perfect way to do it. So you multiply everything in that first row by negative 2. So you get negative 2x, negative 6x, negative 12. Then when you add, you get negative 2y equals negative 2, or y equals positive 1. And I went back to either equation to plug in 1 for y, and I solved it and I got x equals 3. So that's the point, 3, 1. Same idea here with this one. You start with 3x plus y equals 5. That's that one there. And then this one is 2x plus 4y equals 10. So you get these two guys. Now I thought maybe if I multiply the y here by negative 4, I can get 4y and negative 4y. Sure. Multiply everything by negative 4, even the right hand side there. And when you add them, the y's go away. You just get your x's and you can figure out x is 1. Then I plugged it into the second equation to figure out what y is. Y is 2. So there you go, 1, 2. Okay, 13. Alright, 13, they say graph the solution. They don't give you anything. They don't give you a graph or anything. You've got to come up with the answer yourself. Okay, so you're talking with y equals 2x and y equals x minus 1. I just multiplied this one by, let's see, a negative 1. And that way I'll get negative y and positive y. Okay, so you get 0y, you get minus 1x and minus 1. Throw the x to the other side and you get x equals negative 1. Now when you go back up here, if x is negative 1, negative 1 minus 1 is negative 2. So there's your one point where they cross. Now what about all the rest of this? These are x or y intercepts for y equals 2. 2x. Okay, so your x-intercept, you let y equal 0, and you get x equals 0. If you let, for the y-intercept, you let x equal 0, you get y equals 0. So you get 0, 0. It doesn't have any other intercepts, just the origin. Then the other one is y equals x minus 1. Well, we know it crosses the y-axis at negative 1. And we already know it crosses at negative 1, negative 2, so that's good enough. We can graph it. Now, how do we graph this thing? Well, remember, if you have equality as well as less than or greater than, you draw a solid line. But if you have strictly less than or greater than, you draw a dotted line. Alright, so y is less than 2x, that's this guy right here. And I tried something like 3, 0. X is 3, y is 0, so is 0 less than 6? Yes. So we're going to shade this side that contains 3, 0. 3 zeros on this. I'm looking at this line right here. Y equals 2x. Okay? And with the inequality, and with the test point 3, 0 right there, I get a true statement, so I know I have to shade this side. Now let's take this one, and this one you can choose 0, 0 because it's on that side of this line, and you choose 0 and you get 0 is greater than negative 1. Well, that's true. So you shade the side containing 0, 0. Alright? And so if this one goes this way and that one goes that way, the answer is everything in the middle where they overlap. That's your answer. 15, same idea. You want to graph each of these. I solved it like by multiplying by 2, so I get 2y minus 2y. When I add them, my y's go away, and now I know x is 1. Go back and plug 1 in for x here, and I can figure out that y has to equal 1 as well. So you got the point 1, 1. Okay, and with each one of these, if you try and find a point on this graph, you can find some points pretty easily. I found the point negative 1, 0 for this guy. Okay, and for this one I found 0, 3 for that one. Okay, and so all you need are 2 points. This one has equality, so it's a solid line. This one does not have equality, so it's a dotted line. So the first one is right here. And if we check a test value like, I don't know, 5, 5 over here on this side of the line, 5, 5. 2 times 5 plus 5 is 15. Is 15 less than 3? No. So we do not shade the side containing 5, 5. We shade the other side. Okay? And now let's take this one, and we can try, I don't know, 5 minus 5. You can plug that into the second one. So 5 minus 2 times negative 5, that's 5 plus 10, or 15 is greater than negative 1. That's true. So you're going to shade the side containing 5, negative 5 this way. And where do they cross? Everything in this region right here. And you want to find all corners where these two intersect, and we already found 1, 1.